Hello everyone and welcome to another math tutorial. In this video we're going to look at solving systems of equations. And I know this is a topic that we have spent a decent amount of time on already with a couple of lessons in chapter 1, and we've already talked about it again here in this chapter. I'm going to present you with yet another way that you can solve systems of equations, this time using inverse matrices that we learned about in the last video. So again, solving systems of equations is not a new topic. It's something that we have spent much time on already. And we've got a few techniques that we've talked about in this course to date. First one is substitution method. In substitution method, this is the one where you're going to maybe find one of your equations to rewrite as x or y equals. And then you take the other equation and you substitute that first equation into it. So this would then look like this. Here's your substitution part. And then from there you start solving and you find your first variable and you substitute back in to find the other variable. We've also talked about elimination method. Elimination method is where you try and get a variable to cancel out through adding the equations. So maybe we take this top equation times -2 and makes it this. We leave the bottom equation as it is. And from there, the y's are going to add to 0, and you're off and running. You can solve for x, and then you substitute it in and you find the y value. All right, so those are our two kind of main algebraic techniques which we've learned in the past. We also have this new one that we learned in this chapter on matrices called Cramer's rule. Cramer's rule is the one that uses the determinants of the matrices, where we set up the ratio of determinants and then found the values of our variables that way. So I'm going to show you one other technique for solving systems, and then after that you should have lots of tools ready to go as far as substitution, elimination, Cramer's, or this inverse matrix technique. All right, to get us to that point of using inverse matrices to solve equations, I want to just take a look at a real simple looking problem. If I asked anybody who's probably viewing this video how you would solve this problem, I think almost every single one of you would say that you're going to solve this by dividing by 5 to both sides. And you could certainly do that. Dividing by 5 is going to work, and it's going to get you x equals 6. Now another way that we can do this, and you typically do this when you have fractions as coefficients of the x, is we could do it like this. So we can, instead of dividing by 5, we could multiply both sides. And we're multiplying by the reciprocal of 5. Now the reciprocal of 5 is also called the multiplicative inverse. The idea being is that any number times its multiplicative inverse is equal to 1. So when we take 1/5 times 5, the result of that product right there is 1x or just x. And then that gets x by itself. So it's this idea of using the inverse to eliminate this coefficient, leaving the variable by itself. We're going to steal that idea when we set up and solve with matrices, these systems of equations. All right, so let's show how we can do that with a system of equations. The first thing I'm going to do is write what I call the matrix equation, or we're going to, I guess, re-represent this problem as matrices. So this is what the problem looks like as a matrix equation. All right, so there's our matrix equation. I've pulled out, as a 2 by 2 matrix, I've pulled out the coefficient matrix. I've got this variable matrix, and then I've got the solutions to the equation. And if I were to multiply, right, how do we multiply matrices? We take the row times the column, well, this would be 3x plus 2y, which is exactly what I have right there. And then the bottom row would be 1x plus 4y, which is the bottom row there. And of course, then the top row would equal the 15, which is in the top, and the bottom would equal the bottom row here. So it checks out. I can rewrite this as this matrix equation. Now, from this step, what we're going to do is what we did in that very simple algebra equation on the previous slide. We're going to rewrite this like this. All right, so in this step, what I have done is I have multiplied to both sides of the equation, right here and right here. I have multiplied by the inverse matrix of this coefficient matrix. So that's just like in the last slide where I took the 5x, I took times 1/5, and whatever I do to one side, I do to the other side by multiplication property of equality. That's the same sort of idea here. And just like in the last example slide, any number times its inverse is equal to 1. It just cancels out. Well, we know from the previous video that any matrix times its inverse is the identity matrix, which is essentially like 1 in real numbers. So what happens here is that these two matrices are going to cancel out. So I'm going to cross those out. And they leave behind simply x and y, my variable matrix. So xy is equal to this product, whatever this comes out to be. Now, we've got our calculators to help speed up that product, and so we're certainly going to do that in the future when we do our next example problem. But if you multiply those together on the calculator, you would get the solution 4 and then 3/2, which then tells us that solution is 4 is the x, that's on top, and then matching up the y values, or the bottom values, we get that. So that's the idea, is we're going to use matrix inverses to cancel out these coefficients and just leave the variables all by themselves. All right, this example, we're going to solve this one all the way through with the help of the calculator. We're going to solve this system using an inverse matrix. So I'm going to start by writing my matrix equation, which is this. I need my coefficients, 5, -2, 2, 3. I'm going to multiply that by the variables, which is x and y. And that is going to equal the solutions to our equation in a 2x1 matrix, -5, 36. Okay, so that is my matrix equation. I'm going to start with that. Now I need to take this matrix and I need to move it to this side. And we can't divide by it. There's no division of matrices. So we do that by multiplying by its inverse. And so it's going to look like this. xy is going to equal the inverse of this matrix. Now, I could find the inverse if I want, or I can just use inverse notation. I'm going to choose to do that. So I want the inverse of this matrix multiplied by the solutions, -5 and 36. Okay, at this point, I'm ready to go into my calculator. And in my calculator, I am going to put this matrix under matrix A. I'm going to put this matrix under matrix B. So go ahead and do that on your own. I'm going to do it as well, and I will just kind of speed up the playback while I put these matrices into the calculator. Okay, so I have matrix A and matrix B inserted into the calculator. All I need to do now is do A inverse times B. So I'm going to pull that up into the main screen on the calculator. So I'm going to pull in matrix A. I want the inverse of that, so I'm using this inverse button right here. I'm going to multiply that times matrix B. And I get an answer for that. The answer then, I'm going to have XY equals 310. So the solution to my system is 3, 10. So there is an alternative way to solving a system of equations. There's no substitution elimination method. We didn't need Cramer's rule. It's very simply just the inverse of the coefficients that you see multiplied by the solutions to the respective equations in the system. Okay, let's do one more example of that. Okay, here we're asked to find the solution to this system. Now I've got a 3x3 system, 3 equations and 3 variables. Inverse matrices can solve this if it has a solution. So let's go ahead and get that set up on paper. Now I'm going to skip the first step this time and just jump right to what I'm going to put into my calculator. So my variables are x, y, and z. I want the coefficient matrix. Now there's 3 equations and 3 variables, so this is going to be a 3x3 matrix. I'm being very careful to make sure that I write all the numbers down correctly, including the negative signs where they're at. So I want the inverse of that matrix. I'm going to multiply that by the 3x1 matrix that represents the solutions to those equations. Okay, so I think I'm ready now to jump into the calculator. And just like on the last problem, we're going to let this matrix right here be matrix A. I'm going to let this matrix be matrix B. So I'm going to speed up my playback as I get that into my calculator. And if you're following along from home, you can do the exact same thing. You can get these matrices into A and B on your calculator. Okay, I've got matrix A, matrix B inputted. Now I want to do the inverse of A times B. So let's pull that up. There's A with the inverse attached to it times matrix B, and I get as my solution the matrix 2, 3, and 4. So my solution to this system is x equals 2, y equals 3, z equals 4. And there you go, it's that easy, solving a 3x3 system. Now I know what you've got to be thinking, right? You've got to be thinking, if that's so easy to do, why do we ever learn substitution method, elimination method? What's with Cramer's rule? Like, why are we doing all these other things if I can just dump a couple of matrices into the calculator, hit a few buttons, and I've got the answer to every system? Well, as oftentimes with things that are super easy like this, there are some limitations to using this method. And so I want to talk about the limitations right here. Okay, so this inverse matrix method or technique is great when you can use it, right? So it's only going to work with linear systems. And so everything we've done so far in this course has been linear systems. What I mean by linear is all the variables are just variables to the first power. We haven't seen any x squareds or y squareds or x cubes or anything like that. If the system is non-linear, then inverse matrices will not work. You're going to need to use substitution method primarily. So we need it for that. It's also only going to work if the system has a solution. Okay? If I give you a system that has no solution or infinitely many solutions, then this technique is not going to work. And I'm going to show you an example of one on the next slide that returns an error that's not going to work on the calculator. And when that happens, you have to revert back to either substitution or elimination method to determine if it's no solution or infinitely many solutions, because when this inverse matrix method fails, it gives no distinction as to which of these two it is. So there are some reasons there that you still need to know substitution and elimination methods. Okay, so here's the last example in this video. We're asked to solve this system. I'm going to jump right into my matrix solution. I'm going to write my variable matrix xy is equal to my coefficient matrix, which is going to be 2, -1, 10, -5. We want the inverse of that times the solution's 12, 20. Okay, so I'm going to start just right with that. It's the fastest, easiest way to do this, provided that it works. So I'm going to go ahead and type this into my calculator. Okay, and when I try to do the inverse of matrix A times matrix B, I got this error. It tells me I've got a singular matrix. So remember what singular means from the last video in this series. Singular matrix means that this matrix right here doesn't have an inverse. Asking the calculator to perform the inverse of this matrix, it can't do it. And why can't it do it? Well, it's because the determinant of this matrix, the determinant is equal to 0. And so because of that, because the determinant doesn't work here or is 0, there is no inverse, and if there's no inverse, I can't do this, right? So I've got a failure in this inverse matrix technique. And if that happens, it's up to you moving forward. How do you want to solve this problem, all right? So if I was solving this, I would probably just go ahead and jump to elimination. I would probably take this top equation times a -5, which would make -10x plus 5y equals -60. I would leave this bottom equation unchanged. And what happens, very quickly I can see that the x's add to 0, the y's add to 0. We get 0 equals -40, which 0 is not equal to -40, which means that we have no solution. Okay, so it's definitely something that you need to know your substitution elimination techniques, because when this doesn't work, and I guarantee it's not going to work every time, you've got to have a fallback. You know, what are you going to do when this fails? Or maybe you don't like this as much. Maybe you'd rather just do elimination method or substitution, and if so, you don't need these. So it's my job to kind of show you all the different kind of techniques and strategies out there, and then it's your job to practice them and decide what you like and what you want to do. So that's it for this video. If you found it helpful, please support the channel with a thumbs up on the video. If you have any comments or questions, drop them below, and I'll see you in the next one.